Good morning, good afternoon, good evening. Whenever you are watching this video, let us welcome you all to our channel Future Endeavors. Okay, in the previous class, we have discussed about some technical terms related to the spherical mirror. We have also understood what a spherical mirror is. Today, we are going to discuss two more terms which were left out in the last class. One is the focus and other is the focal length. So, what is focus for a spherical mirror? Let us understand. Okay, so for this we have to individually consider concave and convex mirror. You have learnt in the previous class that there can be two kinds of spherical mirror. One is the concave and one is the convex. Okay, so first if we consider write down the heading. Subtopic is focus. Okay. Under that, first we will discuss about the focus of a concave mirror. So if we consider a concave mirror, it's something like this, and the concave mirror has a principal axis, something like this. Okay. Now, the back side of the mirror is in silver. If we consider light rays coming parallel to the principal axis from infinite distance, say something like this, they will get reflected and pass through a certain point on the principal axis. Likewise, if I consider another light ray coming parallel to the principal axis from infinite distance, it will also pass the principal axis through the same point through which the previous ray has passed, something like this. So if you consider the two rays, you can see that the two rays which were coming parallel to the principal axis, after reflecting through the mirror, passes to a point on the principal axis. Now, this particular point is called the focus for a concave mirror. So, how can we define focus for a concave mirror? So, for a concave mirror, we can say that, how can I define focus? Can I define it like this, that for a concave mirror, focus is a point on the principal axis through which light rays, incident light rays coming parallel to the principal axis after reflection from the mirror passes through. Isn't it? Can you define it like this? Yes, definitely. So, focus for a concave mirror can be defined as the point through which the incident light rays coming parallel to the principal axis after reflection passes. Okay, so this is the definition for focus of a concave mirror. Now, what can be the case for a convex mirror? How is it different for a convex mirror? We know that for a concave mirror, the light rays are actually meeting at a point. It's an important fact that the light rays are actually meeting at a point. If I consider a convex mirror, something like this, and for a convex mirror, you know, the inner surface is silvered. So if I consider this is the principal axis, the inner surface is silvered while the reflection takes place from the outer surface, isn't it? Fine. So if I consider that two light rays coming parallel to the principal axis from infinite source, from far off a distance, moves like this, gets reflected like this, gets reflected like this. If see, the light rays here for a convex mirror do not actually meet, isn't it? But if we just extend backward the two reflected rays, we certainly get a point on the principal axis at which the light rays, reflected light rays, seem to be diverging from. This is a very important fact. It is not actually the reflected light is not actually meeting, but if we just trace back those light rays, reflected light rays, they appear to meet at a point, or we can rather say it also like in this way, that they seem to diverge from a point, isn't it? This particular point for a convex mirror is defined as the focus. So for a convex mirror, how can we define focus? So focus is defined as a point. Focus for a convex mirror is defined as a point on the principal axis from which the reflected light rays, if the incident light rays are coming parallel to the principal axis, the reflected light rays seem to diverge from or you can also define it like this. For a convex mirror, focus is a point on the principal axis at which, after the incident light rays are coming parallel to the principal axis, after reflection seem to meet at. Okay, so this is the definition for a focus of a convex mirror. So here actually the light rays are not reflected, the reflected light rays are not actually meeting, but in case of concave mirror they are actually meeting. Now from this we can also get the concept of another thing which is called the real image and virtual image. As you can see, for a concave mirror, the image, although this is image is reduced to a point, okay, but the image is formed by the actual intersection of the reflected light rays. So this kind of image, where the reflected light rays actually intersect to form an image, is called or are called real image. Okay, real image. Whereas consider the case of a convex mirror, the light rays are not actually intersecting at any point, they are seeming to or appearing to meet at a point. In that case, it is called the virtual image. The image is formed, although here it is reduced to a point, but the image is being formed by not the actual intersection, rather if we just trace back the reflected light rays, then we can get the image, and that is called a virtual image. So I think the concept of virtual and real image is quite clear to all of you by now. Okay, so this was the focus, and another definition was left out, the focal length. If we consider the concave mirror, this is the pole, and the gap or the distance between this pole and this focus is called the focal length. In case of convex mirror also same thing, this is the pole, the distance between the pole and the focus is regarded as the focal length. So I hope the concept is clear. The focal length, so focal length, the distance between the focus and the pole of a spherical mirror is called the focal length. Fine. So I think that all the terms related to spherical mirror are clear to all of you by now. Fine. Okay. Next, the next thing that we are going to discuss is the image formation in a spherical mirror. Image formation in a spherical mirror. So for getting the image in a spherical mirror, we need to consider at least two light rays. Okay. So for getting the position of the image or the nature of the image or how the image is formed, we need to take at least two reflected light rays. Okay. So first write down heading convenient rays for ray diagram. So this is the topic that we are going to discuss. Convenient rays for a ray diagram. See, there are actually three convenient rays that you can consider. Among those three convenient rays, only two are sufficient enough to draw a proper ray diagram for a spherical mirror. Now, first convenient ray, we have already seen that when light rays are incident on the spherical mirror parallel to the principal axis, this kind of light rays after reflection, they seem to pass through the focus. So this is the first convenient ray that you can consider, the light rays coming parallel to the principal axis. So light rays coming parallel to principal axis. So this is one of the ray that we can obviously consider for our image diagram, ray diagram, principal axis. And according to the observations, we have found a rule that whenever light ray will be coming parallel to the principal axis, definitely after reflection it will pass through the focus of the mirror. So just if I diagrammatically show, we have already shown it for a say concave mirror, it will be something like this, that light rays coming parallel to the pencil axis, after deflection they pass through the focus. For a convex mirror, you know that the light ray will not actually pass through the focus, rather the reflected ray will appear to be coming from the focus, or it will seem to be as such that the reflected ray is traced back, then it definitely passes to the focus. So this is the first convenient ray that you can consider for drawing the ray diagram. What is the second convenient ray? Just the opposite. Consider when a light ray is incident through the focus, that is the light ray is coming in such a way that it passes through the focus and falls on the spherical mirror. What will happen to those kind of light rays? Those kind of light rays will get reflected parallel to the principal axis. So second, light rays incident on spherical mirror through focus. This kind of light rays after reflection will come out parallel to the principal axis. That's the reverse thing. In the first case, the light rays after reflection pass through the focus. In the second case, the light rays after reflection will pass or will come out parallel to the principal axis. So if I just consider the ray diagram for a concave mirror, it will be something like this. Say this is the focus and the light ray just passes through the focus and is incident on the mirror. Then after reflection, the light ray will just move out in a parallel direction or parallel to the principal axis. So this is the fact that we are trying to understand. Okay, for a convex mirror, it will be something like this. It is appearing that the light ray is coming and falling on the focus. It is not actually falling on the focus, but it is appearing to be such. And this kind of light ray after reflection will pass out parallel to the principal axis. Okay, so this is the second convenient ray that you can consider for drawing the ray diagram in a spherical mirror. For a spherical mirror. Third convenient ray. What is the third convenient ray? So let us consider third convenient ray. Third convenient ray. So the third convenient ray is light ray passing through center of curvature. Now what do you think will happen to this kind of light rays which are passing through the center of curvature? Can you imagine? Say if a light ray is passing through the center of curvature, first let us consider the concave mirror as usual. For the first case we are considering the concave mirror. Now so this is the center of curvature C. Okay. Now a light ray is incident through the center of curvature on the spherical mirror. In that case, what will happen? See, when the light is passing through the center of curvature, actually it is when the light ray is joining to a point on the spherical mirror, on the surface of the spherical mirror, this length, can you see? Yes, this length is actually the radius of the curvature, isn't it? Now you must have read in mathematics or you must be doing in geometry that for a circle the radius is always perpendicular to the tangent drawn at that point. Okay, so if I consider that the light ray is passing the C and falling on a point say M on the mirror, then this particular point, this particular part of the light ray CM, isn't this the radius of the curvature, same as the radius of curvature? And if we draw a tangent at this point M, then what will happen? The light ray CM is actually perpendicular to this tangent, or you can consider perpendicular to the tangent at the point M. Now when a light ray falls perpendicularly on a surface, we have discussed this, when a light ray falls perpendicularly on the surface, angle of incidence is 0 degree. So by the law of reflection, what will be the angle of reflection? It will be also 0 degree. So angular reflection 0 degree means, what does it mean? It will, the reflected ray will just reflect back along the same path along which the incident ray came. So this is the direction of the incident ray as well as this is the direction of the reflected ray. So when we are considering a light ray passing to the incident to the center of curvature, it will just reflect back along the same path along which it came. So I think this concept is clear. Sometimes theoretical question also comes like this, that why a light ray passing through the center of curvature moves back or reflects back along the same path along which it was incident. So this is the reason. So I hope the answer is clear. Okay, so these are the three convenient rays that you can consider for drawing the ray diagram. Okay, so today we are ending our class here. In the next class we will be discussing, or we will be just drawing the ray diagrams for particular convex and concave mirror for particular positions of objects, and we will be seeing how the images are formed, what are the nature of images, what are the position of the images. Okay, so till then please do study well. If you have any query, do mention in the comment box. We will be happy to solve your problem. Till then, thank you, goodbye.